In the previous video, we started working on the main flames of this campfire, making a shader and particle system. Now let's add some distortion to the fire by doing some UV manipulation. Right now, I'm going to try to give a quick and intuitive explanation of UV distortion that applies specifically to a default quad mesh without actually explaining what UVs are. The point of this is to achieve results without explaining too much information at once. In a future video, when I show you how to make the fireball, then I'll have a more thorough explanation about UVs. And by that point, you'll already have an intuition of how UV manipulation works. So all you need to know about UVs right now is that the U and V coordinates on a mesh are what determine how a texture gets displayed on that mesh. So if we alter the UV coordinates that we input into the sample texture 2D node, it changes how the texture is displayed in our particles. Currently, our render mode is set to billboard, which basically means it's using a quad mesh that's constantly updating so it always faces the camera. So as you can see, the UV slot of the sample texture 2D node expects a vector 2 as the input. And this UV0 means if there is no input, use UV0 as the default, which means if we plug in this UV node set to the UV0 channel, it won't do anything because the texture node already uses these values as the default. You might notice the UV node actually outputs a vector 4, but remember, because this accepts a vector 2, the extra 2 values get dropped, which is also indicated by the subtle color change in the wire. For now, you can forget about this and just pretend it outputs a vector 2, and you can forget about there being other UV channels. To achieve UV distortion, I'm just going to separate the U and V coordinates with the swizzle node, then do some simple addition and multiplication to each, and then combine them into a vector 2 before plugging it in to the texture node. So let's start by doing some addition. Here we learn that adding positive and negative values to the U coordinates makes the texture move left and right respectively. And adding positive and negative values to the V coordinates makes the texture move down and up respectively. When values of the U or V coordinates start going above 1 or below 0, the texture node basically wraps these values around to being between 1 and 0. To help you visualize that, let's use the modulo node. But this node won't be in our final shader because it actually causes artifacts when used in this way. Notice how when the modulo node starts wrapping around, the texture preview also starts wrapping around. Now let's create a new texture node, because so far we've just been uniformly adding the same value across the entire U and V coordinates. We can have some areas that add a particular value to the U-V coordinates and other areas where we add a different value. And this is what creates distortion. One way to achieve this is to add values from a texture to the UV coordinates. This sample texture 2D node works the same way as the other one that I explained below. At the moment, I picked a white texture. Before plugging it into the add node, let's first multiply the values that are output from this texture node. Remember, 0 times anything is 0, but if we multiply by non-zero numbers, we achieve the same results as before. You can simply think of this multiply value as a way to change how much influence the texture has on the U coordinates. But now let's switch to this other texture that I made for this demo. The black area of the texture is 0, so no matter how much we increase the multiply value, it won't cause any changes to the U coordinates. And basically, the lighter values in the texture will cause more offset in the U coordinates than the darker values. It's the same principle for the V coordinates. Now let's change this to a seamless noise texture that I made in Blender. I'll leave a link to it where you can download it, unless I forget to do that. Now we are still doing the same thing we were doing before, but this texture has way more variation of black and white, so it causes a proper distortion in our fire. Let's delete that connection and alter the U coordinates so you can see how that looks. I feel like you can't clearly see the wrapping around in the modulo node anymore. Let's set this up so we have a separate multiply node for the U and V coordinates, so we can change the horizontal and vertical distortion independently. This setup uses a lot of nodes, so I'm going to clean it up, but feel free to continue working like this. Just remember to delete the modulo nodes. Let's use the swizzle node to extract just the U and V coordinates, which are the first values from the UV node. We can do addition to the first value of this vector 2 independently from the second value if we do addition with another vector 2. So let's multiply the output of our texture with a vector 2. We're getting a float value from our texture, but because it's multiplying with a vector 2, the output of the multiply node becomes a vector 2. To achieve this, Unity basically duplicates the output of the texture, and this new copy gets multiplied with the second component of the vector 2. A vector 2 is basically just a container with two numbers. The first number is called the x component, and the second number is called the y component. When you add vector 2's together, you simply add the x components together and the y components together. Let me give you an example using annotation similar to what you would get in programming. When you add these two vectors together, you get a vector with the values 0.3 and 1.2. Now let's make this vector 2 be a property so that we can edit it differently in each material instance and see the changes in real time. You can do this by converting it to a property or by creating a new vector 2 property. And you can just give it whatever name you want. I'm setting it to have a little bit of distortion in the V direction. Just 0.1 is enough for now. Now I'm going to add an offset to the U and V coordinates of this noise texture in the same way we did it for the main fire texture. Because we have a bit of distortion in the V coordinates of the fire texture already, if we now move this noise texture, it'll make the distortion move. Make sure you don't get confused and think that somehow these U coordinates will only cause change in the U coordinates of the fire texture. Right now we're doing addition to these U coordinates to make the noise texture move left and right. That's it. These offsets to the U and V coordinates are just about changing the noise texture. They are not about which direction the fire will be distorted. That's what distortion multiplier is for. Let's alter this so instead of us manually changing these addition values, we use the time node to continuously change the coordinates. The time output slot of the time node is basically the time in seconds since you opened Unity or since the game started playing. So it's a number that increases at the speed of time. Again, here is the modulo node with B set to 1, so it wraps around at intervals of 1. Although it might not be very helpful now because the noise texture is seamless, so you can't see it wrapping around. Anyway, let's multiply the value of time so we can change the rate at which we add the V coordinates. As an example, if we multiply by 2, after 10 seconds it will add 20 to the V coordinates because 2 times 10 is 20. In comparison, 0.5 will yield a slower rate of offset because after 10 seconds it will only be at 5 because 0.5 times 10 is 5. A negative value like -1 will make the rate of change increase in the negative direction. After 10 seconds, it will be at -10. By the way, for every one whole number we add to the v-coordinates, it produces one full offset of the texture, if that makes sense. Now let's condense these nodes down with the same approach as before. Let's multiply time with the vector 2 property so we can change the u and v coordinates separately. I'm making the texture move at 0.2 full offsets per second in the u direction and -0.3 full offsets in the v direction. Let's save this and see our particles being distorted. Here it is without distortion, and back to having distortion. I'm going to change the sort mode so we see the oldest particles in front, because I think it looks better when we see the oranges more. Remember, they each start yellow, then become orange, then red. At the moment, the values of the noise texture, which range from 0 to 1, are being multiplied with 0.3, so overall it distorts the fire texture downwards. But I think it's better if the distortion is evenly spread, so it doesn't have an overall movement that's either up or down. To achieve that, we can subtract, or in this case add a negative value, to the output of the texture. Assuming that this texture I made ranges evenly from 0 to 1, if we now minus 0.5 from it, the values will range from -0.5 to 0.5. So our distortion multiplier will produce positive and negative values evenly spread. Let's set the speed to 0 so you can see it more clearly. See how I can change the intensity of the distortion, but it doesn't move up and it doesn't move left anymore? Previously, you could clearly notice the distortion was moving the fire in a particular overall direction. Alright, so the values that I settled on for the fire particles were these, but choose what you think looks best. There are moments when the distortion causes the fire to reach the edges of the billboard. This looks bad, but we can fix it by clamping our fire texture and adjusting the size of the fire texture, so it won't go too close to the edges. I'll start by quickly demonstrating that in this new shader I set up. Again, I won't get too mathematical yet, I just want to give you an intuitive demonstration. When you multiply u or v coordinates, this changes the size of the texture. Remember that any number multiplied by 1 is itself. By the way, I'm now using the fraction node instead of the modulo node, but in this situation, it visually does the same thing. It's like a letter with a height of 1 every time we would reach 1, we jump back down the ladder to 0. So let's see, if we multiply the u coordinates by numbers greater than 1, it makes the texture tile horizontally. Multiplying by 2 makes it tile twice, multiplying by 3 makes it tile 3 times, and so on. Hopefully you can see that there is a direct relationship between the tiling we see in the fraction node, in the combine node, and in the texture node. A similar thing happens in the v coordinates. Notice how when you start going below 1, it makes your texture stretch. Now I want to make my texture not tile because the campfire texture we made isn't supposed to tile. We just want to scale it down so it doesn't go to the edges of the quad. I thought this texture would be set to repeat because it's tiling, but it's set to clamp, which means it shouldn't tile. And I realized that the culprit was the fraction nodes. So let's delete them, because we actually want the values that we plug into the UV slot to be able to go beyond 1. Now as we increase the multiply number, we don't get tiling anymore. But notice how the scaling of the texture is anchored to the black parts of the U and V coordinates. By the way, remember 0 is displayed as black. For our fire to tile from the middle, we need to move that black area to the center. Then we do our scaling, then we push back the black area back to its original position. U coordinates go from 0 on the left to 1 on the right. So we simply need to subtract 0.5, then multiply, then add 0.5 to push it back. Remember, I'll explain more about UVs in the fire projectile tutorial, so you don't really need to know that coordinates go from 0 to 1. Just notice visually that there is a logic to this. Now let's set the multiplication to 1 so we can see the default texture. And if we start to increase the multiplication of the U coordinates, now we can see that the altered U coordinates are anchored to the middle, which corresponds to the texture scaling also being anchored to the middle. Again, a similar thing happens in the V coordinates. Now let's use our actual fire texture. I can see we need to set the texture asset to clamp. If you have your project window open, you can click here to make Unity find the asset texture. Change it to clamp and click apply. By the way, these other settings can be really useful too. For example, per axis lets you clamp horizontally but tile vertically, or vice versa. Keep in mind there are other ways to adjust whether the textures tile or not, depending on your situation and preferences. Now let's make our texture tile in our actual fire shader. Remember, both the U and V coordinates get a subtraction of 0.5. So we can use one subtraction node and one float node with a value of 0.5. The float value does get converted into a vector 2 as indicated by the subtle change in the color of the wire from blue to green. But I prefer this way so we know that the values are supposed to be the same. Plus it looks cleaner. Then we multiply. I want to adjust the vertical and horizontal size of the texture independently. So I'll need a vector 2. But if you always want the same proportions, you can just use a float. And remember that both the U and V need to have 0.5 added after the multiplication. I want to be able to adjust the size of the flame texture in each material instance, so I'll create a vector 2 property. I decided to doze off for a second before finishing the name of the property. With the property selected in the blackboard, you can then go over here in the graph inspector and set the default size to 1 in the x component of this vector and 1 in the y component. And I felt like changing the name again. For the rest of the tutorial, all I'm going to do is just keep changing the name of this vector 2 property. Actually, this name is good. So, after you plug it into the multiply node, you can change its value to see the texture change. I actually changed my mind about how I made the texture clamp, so I set the texture asset back to the default of repeat. Then in the shader graph, this way your original texture asset is untouched in case you need to reuse it in other situations where sometimes it's clamping or repeating. Now let me update the values of the fire material to get the look I want. I want to be able to see the edges of the quads, so I'll check Selection Outline. I'm going to freeze the playback time to when there's just one particle, so it's easier to see if the texture is touching the edges. You can left click and drag on the text that says playback time. Dragging left makes it go backwards in time. These values look good to me for now. From this angle, the movement of the distortion of the fire makes sense. It goes upwards relative to the camera, but it looks bad from above. This is because the particles are set to billboard, so they rotate to face the camera. So now the movement looks parallel to the ground, not upwards from the logs anymore. The way I decided to overcome this was a two-step process. Let's do step 1. Switch it to be a stretched billboard and adjust the fire particles accordingly. You might have noticed that setting it to a stretched billboard changed its pivot. We're going to adjust that later. But let's quickly fix the length scale. You can hover over length scale and read about it more and have a go at changing the values, but I'm just going to set it to 1, so it doesn't cause any stretching. The functionality I want from the stretch billboard is just the fact that it makes the particles face you as you move around while also staying perpendicular to the ground. Another quick note, when using stretched billboard, particles need to have movement, for example via start speed or velocity over lifetime. Otherwise, it won't work because particles won't know where to point. Anyway, let's fix the rotation. It rotated the quad 90 degrees clockwise, so now the flames are pointing to the right of the screen. There are many ways of fixing this, but the way I decided on was by rotating the texture in the shader. Our texture is pointing up in the shader, like this, but setting it to stretch billboard makes the particle look like this. So we want to change our shader to have the texture rotated like this, so that the stretch billboard will then make it point up in the direction we want. To explain shader rotation, I'm using this texture from a random asset pack I bought, just because it's easier to tell what the right way up is. To make the texture rotate, you can use the rotate node. I usually like to set it to degrees. Hopefully you can see that there is a direct relationship between rotating the U and V coordinates and the rotation of the blue wolf texture. Also, you might notice that these new gradient visuals look very similar to the original unaltered U and V coordinate visuals, but just swapped around. Here are the original untouched U coordinates. On the far left, it has a value of 0, which Unity displays as black, and on the far right, we have a value of 1, displayed as white. If we take each of these values and subtract them from 1, we end up with a mirror version. You can use a subtract node or the 1 minus node, like I did. This yields the same result for our wolf texture. And these rotated U coordinates are exactly the same as the original untouched V coordinates. And in fact, this is a more optimized approach if you know you just want a 90-degree rotation. So now let me do this in my demo fire shader graph. Quick side note, you may notice my shader graph looks different because I selected the nodes related to the distortion and grouped them together. Anyway, we have to first figure out where the rotation functionality should go. For example, should it happen after we distort the texture or before that? I think it makes sense to rotate the UVs after the distortion, like I did here initially. So in hindsight, that's what I would have settled on. But in my case, it didn't matter much either way. Let me adjust these properties. I'll make it so there's only one particle to make it easier to see the results. When I'm editing a particular property, sometimes I'll zero out the other ones temporarily so I can see better the results of the current property I'm working on. If you like, spend a couple of minutes coming up with values that you think look nice, but keep in mind we still have more changes to make to the shader and particle system in the next couple of videos. These are the values I came up with for now. I also changed the start size of the particles to range from 2 to 3. That's it for this video. In the next one, we're going to fix the fire clipping against the logs, and we're going to make the fire dissolve away, among other things. I hope you found this video useful. The last thing I want to say is that when you're making VFX, you should always remember, no matter what, the most important